This is another interesting problem which we have. This is an important problem which appeared in JEE a few years back. We are given with f of x minus y is equal to fx gy minus fy gx. G of x minus y is given equal to g of gx gy plus fx fy. We are given that the right hand derivative of function f at x equals to 0 exists, and we need to find g dash 0. Now in order to proceed with this problem, we put x equals y in the first equation. This is the first, this is the second equation. We put x equals y to get f of 0 is equal to 0. Now in this equation, or rather in the first equation only, if we put y equals to 0, we get fx is equal to fx into g0 minus f0 into gx, and f0 is 0, so this becomes equal to 0. On comparing both sides, we get g of 0 equals 1 because f of x cannot be equal to 0. So we got f of 0 equals to 0 and g of 0 equals 1. We would write these results. Now we have got two results which are f of 0 equals 0 and g of 0 equals 1. Now we are given with the fact that right hand derivative of function at x equals 0 exists. So we find f dash 0 plus as limit h tending to 0, f of 0 plus h minus f of 0 which is equal to 0 upon h. This is equal to limit h tending to 0. Since we have f of x minus y type of format, so we convert this also in f of x minus y format by making f of 0 minus h. This becomes limit h tending to 0 upon h. This becomes limit h tending to 0, f of 0 g of minus h minus f of minus h g of 0 upon h. Now f of 0 is 0 and g of 0 is 1, so this becomes limit h tending to 0 f of minus h upon minus h. This becomes equal to limit h tending to 0 f of 0 minus h. Since there is 0 written over here and f of 0 is equal to 0, so this becomes equal to f of 0 minus h minus f of 0 upon minus h, and we know that this is equal to f dash 0 minus. So f dash 0 plus is coming equal to f dash 0 minus. Hence the function is not only differentiable at x equals to 0 plus, but the left hand derivative is equal to right hand derivative, and hence the function is differentiable at x equals 0. So we have proved that f is differentiable at x equals to 0. Now g of x minus y was given to be equal to gx gy plus fx fy. Putting x equals to y, we get g of 0 which is equal to 1 is equal to g square x plus f square x. Now this is differentiable, fx is differentiable, so gx has to be differentiable at x equals to 0, because sum of two differentiable functions is always a differentiable function. So we have proved that g of x is differentiable at x equals to 0. So differentiating both sides, we get 0 equals 2g0 g dash 0 plus 2f0 f dash 0. f0 is 0 and g0 is 1, so g dash 0 is equal to 0, which is our final answer.